So we did have you on, as I said, a little over a year ago. That was episode 753. And so in that, our listeners did get an overview of what Zerve was like. But I understand that you've released quite a few new features since then.
Yeah, it's been a wild year. We did some real basic stuff like integrating with GitHub and Bitbucket and stuff like that. But we also have added a feature called the Fleet, which is coming out like this week, and that's a way to massively parallelize code execution using serverless technology. So you can, if you wanted to let's say you wanted to make a call to a large language model, but you wanted to do it, say, 1,000 times. They're slow, right? Like everybody's used ChatGPT. You could type it, ask it a question. It might take, 20, 30, 40 seconds for it to come back. So if you're trying to do that 1,000 times, doing it in series is a kind of a pain. But so you could do like multi-processing or something like that, but then you got to like manage the pools and like figure, there's a coding challenge there. Maybe not a challenge for the experts, but it takes more than one line of code. But Zerve is block based. You've seen it. It's the code is arranged as a DAG, and so each block, when you execute it, spins up serverless compute and executes. Well, it turns out that it's dead easy to just parallelize by spinning up lots of serverless compute. And the upside is, you don't have to write any code to do it, and it doesn't cost more because it's the same amount of compute. It just happens all at the same time. So the Fleet is pretty awesome. And then our AI assistant that kind of like can help you to write code within the app, can build its own blocks, can do some of that stuff. It's sort of modern coding, because the large language models really revolutionized the way people code. It's just not at all the same kind of endeavor as it was. So yeah, some really, really cool stuff.
100%. And so Zerve in general is about creating code faster, easier to understand, easier to collaborate on. So we'll get into those details like the AI system, which accelerates that even more. We'll talk about the LLMs and that kind of parallelization, the serverless aspects of that as well. But quickly first, we should, for folks who haven't listened to episode 753, we should fill them in a bit more. So now we know it's a directed acyclic graph. So maybe we should kind of explain that term a little bit. So for example, so a directed acyclic graph, it's basically what it says. Everything's in there in the term. But to break it down, you have a graph, which means you have nodes and edges connecting those nodes. It's directed, which means you have some kind of flow. It's not just that the points in the graph are connected, meaning like, oh, these are all my friends who are connected in a graph. No, it's directed. There's some kind of flow of information between all those nodes in the graph. So it's like outlining a process, like a data science process, a data modeling process, a data engineering process. All that stuff could be nodes and directed edges in your DAG. And then the final term there, the A, means that nowhere in your directed graph is there a loop.
You got it. Yeah, that's a good description. Yeah, in Zerve's graph, we call it a canvas. The code lives in the nodes in your graph, and then the connections indicate data and memory flow, right? So if I execute my first block and it is, say, a SQL query to a Snowflake database, then the data frame that gets created will pass down that node to the subsequent blocks. And you can fork and go 1 to 2, and then you can merge back together and go 2 to 1, and so on. The nice thing about the architecture is that you can run as many blocks simultaneously as you want. So you can have multiple people in the same canvas, all running code at the same time, writing code in Python, in R, in SQL. It's just kind of a wild mix and match environment where anybody can do anything. It's really cool.
That's one of the cool things about it. It reminds me of the shift, and I can't remember if I said this in 753 or not. So my apologies to listeners who listen to that if I'm recycling this analogy again. But what Zerve reminds me of is the shift from having Microsoft Docs that you emailed around to each other and you completely lose track of what versions you're on. Somebody's working on, you have a big legal document and your legal team is making corrections while their legal team is making corrections and you're reading it and taking notes. And then that merger becomes a nightmare. Zerve does the same kind of thing in data science that Google Docs did, where you could all of a sudden be collaborating all together on the same, say, legal document, and you can see when that somebody's typing, you can see that they're leaving a comment, you can do things in real time. You could be potentially on a Zoom call at the same time and talking it over. And so Zerve allows that same kind of interactivity and visibility and parallelization that Google Docs did.
Yeah, exactly. So if you've ever worked in like a Jupyter notebook, then you know that sharing and collaborating on those is a nightmare, right? Like
And
you
commits
yeah.
and like
Well, every time you
resolving
open it, the
commits.
metadata changes, so
Yeah.
you end up with tons of merge conflicts and all that stuff, which is a nightmare. And so you end up with files that are like, document final, final, like document really final this time. Use this one. You know what I mean? So the file naming is hilarious.
Yeah. And so the net effect with a tool like Zerve is that, according to your materials, and so you're going to have to explain this to me, it says that it empowers code first data teams to cut cycle times by up to 9 times. So there's a couple things that's interesting about this. So the first thing is code first data teams. It sounded like when you described that DAG that it could be a low code, no code tool. But in fact, you're talking about empowering code first data teams. So that's something to clarify first. And then how does Zerve empower code first data teams to cut cycle times on model development up to basically 10x?
Well, yeah, code first it's definitely not a no code, low code tool. Although large language models are making that a little bit fuzzier. The 2010s was really like the era of the low code, no code tool. I was at Data Robot, one of the original low code, no code data science tools. I was there for 7 years or so, and I think everybody has pretty well realized that low code, no code, the emperor's got no clothes on that. Like anytime you run into a complicated problem, you're going to exceed the bounds of what you can do in a low code, no code tool. And you're going to have to, and that's why they all like Data Robot bought a notebook environment. Databricks introduced a notebook environment. Like they're all kind of shifting to coding environments because they're realizing that the only people that actually generate value from data are the experts, the ones who are writing code. And so we very much started out as a coding environment, a place where you could write code, and we still are. Like there's been no pivot. We are a coding environment, but now with large language models, it's it's not exactly the same type of thing. Like you're not coding the same way that you were, where you'd sit down at a blank screen and just type code. Instead, you're sort of describing to the large language model what you want to build, and then you're taking that code and maybe you're tweaking it, or maybe you're interacting with the large language model to make it do what you want it to do. And so it's still very, very code based, but it's just a different experience. It's really wild how coding has changed over the last in such a short time, over the last 2-3 years.